And straight after that, we've got Poppy. If you haven't seen Poppy's channel, go and check him out too. He's good for a chat, he's fun, and he makes cool stuff. And straight after that, we've got Poppy. If you haven't seen Poppy's channel, go and check him out too. He's good for a chat, he's fun, and he makes cool stuff.
Hey gang, Poppy here. This is an educational, non-machining, non-humorous, mostly, video on reamers. I'm in great debt to Quinn Dunkey. As 2 days ago, as I'm recording this, she posted a video where she was talking about the classes of fits. And I'm not going to quote her, I'm not going to try, watch her video, but she was talking about how reamers are a very easy way to increase the quality of the holes you make. Easy, fast, and even in my case, at over $200 for a set of reamers, cheap. Hey now, there are two generally agreed guidelines for using reamers. Run them a little slower, right? And use lots of lubricant. Almost everyone agrees, run them a little slower and use a lot of lube. Here's 2 rules, or maybe more. You never, ever, ever do any of these things. Do not stop a reamer in the hole. Ever. Do not run a reamer backwards. Ever. And of course you don't want to crank the reamer out still. Well, that's 3 things. Any of them will destroy a reamer in a big hurry. You hear people talk about lift your file on the backstrap so you don't curl the teeth over and make them round and it stops being a file and becomes a bumpy burnisher. That happens to reamers. Never ever stop it in the hole and never ever run it backwards. Nice and slow, lot of lube. Nice and slow go in. Remember, you're not trying to push this reamer through the hole. You're gently giving it enough pressure so its teeth, or what counts for teeth on a reamer, can gently, precisely cut around the hole. That's the size the reamer says it. And you slowly bring it back out. Then you can stop the spindle. Never ever stop it while the reamer's in it, and never ever run the reamer backwards. Do it in a shop, they'll fire you. Do it with your own stuff in your own shop, well, it's your money. If you're replacing reamers a lot, or being one of those people, oh, reamers ain't worth a shit. Now you know why. Okay. I myself, I state emphatically that reamers are the fastest, easiest, and cheapest, even at $200 for a set of reamers, cheapest way to increase the quality, the roundness, and the dimensional stability of the holes you drill. Now, let me show you something. First, a disclaimer. I have absolutely no connection with Schar's Tool Company other than I spend money there. Okay? I buy stuff from them. Like these. Number 1, number 60. High-speed steel chucking reamers. I've been wanting them over 40 years. I finally had all the circumstances fall into place exactly right now. I've got them. Beautiful, aren't they? Now, why reamers? Why they're the easiest? Look at the size of them reamers. In that case I just showed you. Are you going to try and bore, single point bore a hole the size of any of them reamers? Really? Seriously? Post a video of you single point boring a 93 thousandths hole an inch deep in a piece of steel. Post it to YouTube. I want to see that. Yeah. Now, the history of reamers. Why? For the longest time, drills, see, drills come right after reamers. Drills cause the need for reamers. So you must understand the drill. For the longest time, a drill was a spoon-shaped piece of thing the carpenter was making a hole in a big piece of wood to ram a peg in. Or get started for a chisel to chisel out a mortise. Watchmakers started making drills. They're a piece of steel rod, flattened, cut the angles, right? Put it in your collet and drill a hole. And make them out of steel. They heat treat them, get them all good and hard so they'd cut that brass and bronze. And occasionally silver and gold. They're working with a Lord Muckety Muck's castle, making him a clock. Okay. One day, a clever guy decided, why don't we twist the drill bit, right? Self-evacuate. Well, the caused the problem. They started making triangular-shaped holes. And from my personal experience, the smallest dimension in those holes was the exact size the drill was supposed to cut. So your hole is big. Smart man figured, make these straight flute, and only cut right here, and it's dimensionally good. So we drill a little undersized, then we work this through here really nice and slow, then we bring it back up. Round holes. Believe me, in machine shop, having your hole turn out round is important. Unless you're looking for some strange shape, and we're not going to talk about that now. You kinky little thing, you. We're talking about round holes. Reamers. A lot of the time in tapping holes, they say drill undersize of your tap drill size, ream it to your tap drill size, then tap it. Want to know why? Those triangular shaped holes will break taps like that, especially little itty bitty ones. And those little itty bitty taps, they don't cost much less than the normal size. Sometimes they cost a lot more because they're hard to see and make, because they're hard to see what you're doing. Imagine being the machinist who makes 0.2 millimeter taps and dies. Back in the 90s, there was a point where there was only one guy in Switzerland making them. I hope he had an apprentice. Anyway, that was the story I was told by Otto Fry. So, I tend to believe it. Anyway, small size. You want reamers. Quick work. You want reamers, period. Then we have special reamers. Taper reamers. There's plain taper reamers, then there's taper pin reamers with a specific angle for those taper pins to put machines together with. And there's over and under reamers you use with dowel pins. The one in the part where you want the dowel pin to stay forever, you use the under, and the one in the part you want to slide on and off that dowel pin be the over. And usually 1,000th under and 1,000th over. Just enough to not move and just enough to move with proper persuasion. Gentle. Okay. That's it for reamers. Let's talk about plastic. A couple months ago, I think it was a couple months ago, I was watching one of Stefan Winter's videos, and he was machining this plastic. And I thought he was being funny when he said it eats carbide tooling. But then he showed us what this plastic was doing to his carbide tooling. Can you say eat it alive? Come on. This plastic casing here used to come out like so. In order to get that casing open, I had to cut off the end cap. I used an angle grinder and this. You see that? I ground high-speed steel, Momax cobalt, even. No problem. Just a little bit more under. I cut the end off this motor enclosure, this damn plastic, and look what it did. It made this wheel look like Gabby Hayes. Gabby Hayes had whiskers. See? Serious plastic. That worm screw, motor worm screw enclosure is for my reversible lathe lead screw project. I've decided that motor, with or without that worm wheel and that screw truncated, or should I say abbreviated and turned down for the fitting I'm going to put on it, with or without that worm mechanism, that motor is going to power the lead screw of my lathe. And I've decided that since I have it, it's already paid for and it's here, I'm going to use a Kirby flexible shaft. Anyone who knows about the Kirby vacuum cleaner company knows that they have this accessories they call the butler. Grind, buff, use the flex shaft to buff or drill. You can even use the flex shaft with a special cap and this eccentric weight as a massager. Spray paint and all kinds of stuff, right? That flexible shaft is going to be the linkage between wherever the motor assembly outputs to the lead screw input. Yeah, I've already ordered my power supply. And I'm going to make up a simple 2-bus system with 4 switches, 2 for each direction. They'll be side by side. Jeet, 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 jeet. So I can sit at the lathe and have a nice slow feed. Get to the end of the cut. Very nice it's going to be. And it's not using microprocessors, except for the power supply, speed control. But, as for backwards and forward, that's basic polarized buses. Anyway, I was going to go for now. Good night from California. Oh, another thing. Hey, right here is the right size to go on the worm of that motor. Put a little bit of epoxy in there. Slam! Anyway, I'm going to mill this away here and cut this off approximately there. And the flex shaft latches on here has got a bayonet type fitting. Hey, I love it when a plan starts to come together. Gee, I wonder what show that comes from. Anyway, good night from California. Happy machining, stay safe.